Chapter 8 Homework Questions 2, 6, 13, and 18. Question 2. Answer true or false to the following statement and give a reason for your answer. If a 95% confidence interval for a population mean is from 33.8 to 39, the mean of the population must lie somewhere between 33.8 and 39. This is false. Because it may be between this interval or no, but the only thing we can say that we can just be 95% confident that the mean lies in here. Question 6. Suppose that you intend to find 95% confidence interval for population mean by applying the one mean z interval procedure to a sample of size 100. So the sample size is 100 and the confidence interval is 95%. What happens if we use the same sample but this time 50 instead of 100, but we keep the confidence level the same? What happens? What's going to happen is the precision of the estimate will decrease because the confidence interval will be wider for 50. What happens if we keep this sample size, but if we change the confidence level to 0.90? What happens this time? The precision of the estimate would increase because the confidence interval will be narrower. Question 13, millionaires. There is a survey for U.S. millionaires, and 36 randomly selected U.S. millionaires are have this age. This is the data for the sample. For this data, determine a 95% confidence interval, and the standard deviation for all U.S. is going to be 13, and the mean of this data is 58.53. So how we do this, how we find the confidence interval, 95% confidence interval. If it's 95% confidence interval, alpha is going to be 0.05, and to find the z value, we get half of this. So we go to the table and check z at 0.025. That's what we get. It's going to be 1.96, and the sample size is 36, and alpha, which is the population mean, standard deviation of the population, is 13. After we get all these, we basically plug them in this formula, and this is the population mean. When you plug all these numbers in the formula, this is how you do that, and you get this interval. 54.3 year to 62.8. This is the confidence interval. Question 18. This is the blood children of diabetic mothers, and there's going to be a table which has the arterial blood pressures for a random sample of 16 children of diabetic mothers. So these are the blood pressures. So how do we apply the t-interval procedure to these data to find 95% confidence interval? What we do is, so the mean of the data is 85.99 and standard deviation of the data is 8.08. So again, if it's 95% confidence interval, alpha is going to be 0.05, and df is n-1, which is there's 16 in here. It's going to be 16 minus 1, which is 15. And what we do is we basically, because it's a t-interval procedure, what we do is we check the table 4 for t value at 0.025 with df 15. And when we do that, we get 2.131. And we just use this formula and plug in the numbers in here. After we do that, this is what we get as the confidence interval. It's going to be 81.69 to 90.30. So what does that mean? It means that we can be 95% confident that the mean arterial blood pressure of a children of diabetic mothers is somewhere between 81.69 and 90.30. Obtain a normal probability plot, a box plot, a histogram, and a stem and leaf diagram of the data. So this is the normal probability plot. We look at the table for normal scores for sample size 16, and we plot the points in here. Frequency table, so between 16 and 70, how many numbers do we see? Between 70 and 80, how many numbers? 80 and 90, how many numbers? This is how we do the histogram. Box and box plot, the median is here, first quartile, third quartile, least number, greatest number, and this is the box plot for the data. Stem leaf diagram. Well, okay, actually, when we go back, the numbers are decimals, so when we do the stem and leaf diagram, this is we should look at the key to understand the numbers. The key says that 12 and this is 3. It means that this means 12.3. It's not 123. It's not 123. It's 12.3. So the least numbers in here is 69.4. Yes, it's 69.4. And the greatest number is 101.9. Yes, it's 101.9. Based on the graphs, is it reasonable to apply the t-interval procedure? Yes, because the sample size is moderate and the graphs do not show any outlier. And the normal probability plot is almost it's almost aligned. It's linear actually. That's why we can do a t-interval procedure.